Okay, I'm teaching you according to the IIT Kharagpur level. Okay, so in the last class we have done mesh analysis, right? Now we'll do the same thing, mesh analysis. Now we'll do from the current source. Okay, if suppose there is a current source in the circuit, then how will you able to solve that kind of question? Now let's study that. Okay. So basically, this type of source is the voltage source, positive, negative. We can represent the voltage source by like this symbol, or we can represent it by like a circle also. But current source is represented like a arrow. It can move upward or it can move downward, right? So there are two possibilities that current source may be in the corner wall or current source may be in the middle wall. Okay. Remember I told you that just imagine this is your house and these are the corner walls of your house and this one is the middle wall of your house, right? So first of all we are studying about that if current source is present in the corner wall like this kind of circuit. Okay, yeah. Now suppose just imagine this is 10 volt, 2 ohm, 3 ohm, 6 ohm and 8 ampere. Again we'll follow the mesh analysis, the KVL rule. We can say mesh analysis also or we can say KVL. So step number one is what is? We have to see how many meshes are there. Just imagine this is your room and in this we are having two meshes. Two meshes means two variables and two equations we need to get, right? So suppose this is the room of I1 and this is the room of I2. Step number one, mark current direction, right? Step number two is to mark sign convention, right? Now we need to mark sign positive, negative, positive, negative, positive, negative, and positive, negative. Always remember we never mark the current sign across the current source. We can mark the sign across the voltage source, we can mark the sign across the resistance, but we never mark the sign across the current source. Okay, clear? Okay. Now step number one is mark current direction. Step number two is mark sign convention. Step number three is apply KVL, right? Okay. So as you know, this is the first mesh of KVL A, B. We can apply in the first mesh. That would be, remember, we always need to take the second sign of the path. Like you are moving from A to B, then B to C, then C back to the position from where you started, right? If you are moving from A to B, what is the second sign that comes in your path? That is negative, right? Resistance is 2, current is how much? I1. If you are moving from B to second sign is negative, resistance is 3, current is how much? I1 minus I2 because both the currents are moving in the opposite direction. I1 is moving up to down, I2 is moving down to up. C to D nothing is there, D to A, then that would be plus 10 is equal to 0. This is your first mesh equation. Okay? Yeah. So always remember, like just in this case, just imagine that current source is your enemy. Okay? Because you got current source here and you stuck with this problem that how will we able to handle this problem. So just imagine that current source is your enemy. Now tell me one thing, what will you do with your enemy? You will kill your enemy, right? Or you will avoid the path where your enemy is present, correct? Killing I'll tell you, but three can't go through the path where your enemy is present. Means suppose B, E, F, C. You are starting from B, you are moving towards E, but you have seen that there is a enemy present in your path. So you will never go through the path where your enemy is present. Understood? Now what's the situation and how will we deal this kind of situation? We'll make one equation directly from the current source. Okay? And if the current source is in the corner wall, then there is a single current flow. If the current source is in the middle wall, then there will be double current flow. Okay. So as you can see that 8 ampere is in the corner wall, there is a flow of single current. Now you can see that I2 and 8 ampere, they are moving in the same direction or in the opposite direction. Can you tell me? 8 ampere. So they are in the opposite direction. So I2 would be equal to minus, right? If they are in the same direction, then that would be positive. If they are in the opposite direction, then that would be negative. Clear? So that is equal to the second equation. Because it's in single current is flowing, so we don't consider I1. This is in the room of I2, right? 8 ampere is in the room of I2, correct? So that would, so now we'll have two variables and two equations. Then we will solve it and we'll get the value for I1 and I2. Got it?